if you have to move towards much faster trains, as we have seen in Japan, in Europe, the bullet trains that were there, you've got one of those coming up soon. How many of those would you like to introduce? What is the balance you'd like to keep between the Vande Bharats and the bullet trains?
So globally, if you see, almost all countries, including Japan, China, Taiwan, South Korea, all of them constructed elevated passenger corridors.
Right.
So passenger corridors are basically elevated and they are designed for 250 to 350 kmph speed, which is what our Ahmedabad to Mumbai corridor is. Once you have elevated passenger corridors, the surface area, the surface tracks, they get freed for cargo movement.
Right.
Cargo should normally move at 60, 55 kmph because cargo train is very heavy. So let's say a normal iron ore train will be 7,000 tons. A normal coal train will be about 5,500 tons. So 5,500 tons multiplied by velocity, that much momentum is there. So that's why cargo train should not have that much velocity. Cargo train generally should move at 50 to 55 kmph as the peak speed, and passenger train should move at 250 to 300 kmph.
And when do you think we could get there in terms of...
Our first corridor is doing very well. It's growing. It's progressing very rapidly. We have already constructed about 235 kilometers of it, and it's going on as per our progress. It's going on very well. In fact, recently the Japanese Prime Minister sent a special delegation to see how India is progressing so fast. They were really amazed, and I must also share with you, many of the people who are working on this project, there are industries from Rajkot, industries from Baroda, they have become exporters of the technology.
Okay.
So this is a very, very interesting thing. These are very precision molds, and these precision molds, when we use them in the manufacturing of girders and all, they started now the focus is on laying more tracks. So in the last 9.5 years, we have laid about 25,000 kilometers of tracks. Wow. Last year itself, we laid about 5,200 kilometers of tracks. So 5,200 kilometers, to give you perspective, entire network of Switzerland is 5,000 kilometers.
Oh, okay.
So it's like
you added a Switzerland.
adding one Switzerland in 1 year. So having more tracks, having electrified railway, producing more locomotives, inducting more wagons, that means as we grow, we should be able to shift a large part of the cargo from road to railway.
What is the percentage right now? If you
So historically, it used to be 80% by rail about 70 years back. Over a period of time, it came down to 27%, and now it has come back to 29%.
Okay. So you are now hoping to up
35% is our target by 2030. And with that, our dependence on oil import should significantly reduce. And over a period of, let's say, from 2030 to 2047, we should be in a position where we should do about 55% of the cargo by rail. So that means our dependence on oil has to significantly reduce, and for that we need investments in railways, and that's what we are using this budget allocation for.
Now we noticed that the speed of passenger, and we're looking at also on the other side, moving people rapidly. The Vande Bharat trains have come in a large way. They're moving at about 160 kilometers, or to what's your max speed that you are looking at the moment? 160, 170?
So at surface, we have to look at the constraints of our country, right?
Right.
When we do transportation on surface, we have to think of cattle which come onto the tracks. We have to think of people who come onto the tracks. We have to look at the almost flat terrain in large parts of the country. With those constraints, we are looking at 130 kmph as the standard speed and 160 kmph in selected sections. When the trains used to run at 60, 70 kmph, 80 kmph, it was a totally different kind of system. When trains started moving beyond 100 kmph, imagine a train which is moving at 100 kmph, the time that a loco pilot gets to see a signal, right, and take cognizance of it and take action on it.
Right.
That is a second or more.
It's like our braking time when we are driving a car.
It's moving it very fast. So the time that you get to see a signal is very, very small, very small, like a fraction of a second sometimes. So all over the world, the railway systems basically took the signal logically, not physically, I'm saying,
Right.
logically through technology into the cab of the driver, which means that the driver is able to see, for example, this is the driver's cab. The driver is able to see what is the signal aspect sitting in the cab itself.
Right.
Signal is, let's say, 5 kilometers away. Physically, the signal is 5 kilometers away. Logically, this driver is able to see the signal in the cab.
Right.
Correct?
Should be, yes.
That is the way ATP works.
Right.
Now, either the driver controls the speed, regulates the speed as per the signal aspect,
Right.
or the system itself will reduce the speed when the signal is asking the train to reduce the speed.
Right.
Correct?
Right. Got it.
Let's
Yes.
say there is a red signal after 5 kilometers.
Right.
Now, a train which is heavy, it has got huge momentum, that has to start the braking almost 1.5 kilometers before.
So it's automated, should be automated. yes.
Absolutely.
Yeah.
So that the entire world moved in 1990s, early 90s, actually late 80s in case of some of the developed countries. Our country had to wait till 2016 to start this journey.
And what have you done since
So
then?
2016, now these are safety systems which are SIL 4, Safety Integrity Level 4. So level 4 means you cannot allow one error in 10,000 years.
Oh,
Imagine the magnitude
Okay.
of this.
right.
SIL 4 standard, Safety Integrity Level 4.
Right.
SIL 4 means you can allow only one deviation from the defined behavior of a system in 10,000 years of operation.
Right.
That is how aviation safety systems are built.
And this is what Kavach is.
Kavach is designed for SIL 4.
Okay.
So 2016, the system was completed. Design was-
Indigenously built, I would gather.
Correct. Our design was completed. 2017 and 18, many of the tests were done. 2019 onwards, the installation started. 2020 and 21 were COVID years. 2021 onwards, the ramp up has started. Initially, 1,500 kilometers per year capacity. Now we already reached about 3,000 kilometers per year. Now we are ramping up to about 5,000 kilometers per year kind of capacity for installing Kavach.